You will understand how Nvidia created a technical and business moat that makes the entire AI industry dependent on them and why competitors can't break free. OpenAI runs on Nvidia chips. Google's AI, Nvidia. Meta's entire machine learning infrastructure, Nvidia. Microsoft, Amazon, Tesla, Nvidia. One company controls 95% of the AI chip market, not because they make the fastest hardware, because 17 years ago they built a cage disguised as a gift. Every AI researcher learned the same programming language, every startup built on the same software stack, every breakthrough was coded in CUDA, Nvidia's proprietary platform that silently locked an entire industry into dependency. Competitors tried to break in, AMD built powerful chips, Intel invested billions, they all failed because the trap was never about the chips. This is the story of how Nvidia engineered the most successful technical lock-in in modern computing history, how a software decision made in 2006 became an unbreakable moat worth hundreds of billions, and why the entire AI revolution now depends on one company's willingness to supply the hardware everyone is desperately fighting to buy. In the next 15 minutes, you'll understand the 4-layer trap that makes escaping Nvidia nearly impossible, the hidden switching costs that keep Google and Meta chained to their ecosystem, and the exact moment when Nvidia's competitors realized they had already lost. Nvidia launches CUDA, Compute Unified Device Architecture, a programming platform that lets developers write code directly for Nvidia GPUs. Before CUDA, using graphics cards for computation required learning obscure graphics programming languages. CUDA changed everything. It looked like normal code, it was easy, and it was completely free. Here's what nobody realized. Nvidia wasn't selling software, they were building a walled garden. Every computer science student who learned CUDA in college became an Nvidia customer for life. Every AI researcher who built models in CUDA created code that only ran on Nvidia hardware. Every startup that prototyped on Nvidia chips locked themselves into an ecosystem they couldn't leave without rewriting everything from scratch. By 2024, CUDA has been downloaded tens of millions of times. It powers TensorFlow, PyTorch, and virtually every major AI framework. The entire machine learning research community speaks one language, and Nvidia owns the dictionary. AMD tried to compete. In 2016, they launched ROCm, their open-source alternative to CUDA. Intel followed with one API. On paper, both platforms work. In practice, they barely exist. The developer adoption numbers tell the story. AI researchers overwhelmingly choose CUDA not because AMD and Intel chips are slower, though Nvidia maintains a performance edge, but because the entire software ecosystem is built for Nvidia. Libraries like cuDNN for deep learning and Tensori for inference optimization only work with CUDA. Switching platforms means abandoning thousands of pre-built tools and starting over. Here's the data center revenue breakdown. In Q1 2024, Nvidia captured $22.6 billion in data center revenue, AMD $2.3 billion, Intel less than $1 billion. Nvidia doesn't just dominate, they occupy a different universe. The hardware everyone sees, the H100 and A0100 GPUs, is just the surface. Underneath runs a software stack 17 years deep. When you buy an Nvidia chip, you're not buying silicon. You're buying access to CUDA, cuDNN, TensorRT, NCCL for multi-GPU communication, and hundreds of optimized libraries that took nearly 2 decades to build. Competitors can copy the chip architecture. They cannot copy the ecosystem. And Nvidia knew this from the beginning. In 2006, when gaming was still their core business, they made a bet: give away the software, own the standard, and wait for an industry to grow around it. When the AI boom exploded in the 2010s, every single breakthrough, from AlexNet to GPT-4, was trained on Nvidia infrastructure. The trap was set before anyone realized there was a cage. Switching sounds simple. AMD's MI300 chip rivals Nvidia's H100 in raw performance. Intel's gaudy accelerators work. Theoretically, any AI company could migrate. Rewriting AI models from CUDA to ROCm or one API isn't a weekend project. It's months of engineering work. Every custom kernel, the optimized code that makes AI training fast, needs to be rewritten. Every performance optimization needs to be rediscovered. Every integration with proprietary Nvidia libraries needs a replacement that might not exist yet. One AI infrastructure expert estimated the cost to migrate large-scale training systems could exceed millions of dollars in engineering time alone. That's before accounting for the performance regression, debugging chaos, and months of lost productivity while teams relearn entirely new tools. For startups, it's even worse. When you're racing to train models before your funding runs out, betting your entire company on an unproven AMD or Intel stack is suicide. Investors expect you to use Nvidia because Nvidia is the de facto standard. Using anything else raises questions about your technical competence. Here's the quiet part. Nvidia doesn't need to block competitors. The ecosystem does it for them. Hiring AI engineers? They learned CUDA in school. University research labs? They publish papers benchmarking on Nvidia hardware. Cloud providers? AWS, Google Cloud, and Microsoft Azure all offer Nvidia instances as the default option, with AMD and Intel chips as niche alternatives nobody uses. The developer community itself became Nvidia's moat. When every tutorial, Stack Overflow answer, and research paper assumes CUDA, trying to use ROCm feels like coding in a foreign country where nobody speaks your language. AMD and Intel aren't just fighting Nvidia, they're fighting 17 years of entrenched knowledge, tooling, and muscle memory across the entire AI industry. In 2023 and 2024, demand for Nvidia's H100 GPUs outstripped supply so severely that some AI startups reported waiting times of 6 months or longer. Nvidia allocated chips based on relationships and scale. OpenAI, Microsoft, Meta, and Google received priority access. Smaller startups scrambled for scraps. You'd think shortages would drive customers toward AMD or Intel. Instead, companies waited. They delayed product launches. They raised more funding to survive the wait, because switching to an alternative meant abandoning their entire codebase and tooling stack. Nvidia controlled both the supply and the demand. They decided who gets to build AI and who gets left behind. The concentration is staggering. Nvidia holds roughly 95% market share in AI accelerators. Not 60%, not 75%, 95%. Every major AI breakthrough in the last 5 years ran on Nvidia chips. GPT-3, GPT-4, LLaMA, Stable Diffusion, Gemini, all trained on Nvidia infrastructure. OpenAI's entire business model depends on access to Nvidia GPUs. When ChatGPT exploded in late 2022, the bottleneck wasn't ideas or talent, it was Nvidia chip availability. Nvidia's data center revenue tells the story of this dominance. From 2020 to 2024, the segment grew from around $6 billion annually to over $90 billion. The company didn't just ride the AI wave, they owned the surfboard, the ocean, and the beach. For the AI industry, this creates existential fragility. What happens when one company controls the infrastructure for the most important technology of the century? Nvidia sets the prices. Nvidia decides the allocation. Nvidia determines who gets to compete in AI and who doesn't. And the dependency runs deeper than hardware. Nvidia's software stack evolves constantly. They release optimized libraries, new features, and performance improvements that keep CUDA ahead of competitors. Every update makes the moat wider. Every new tool increases switching costs. Critics argue this creates a dangerous monopoly. When the entire AI industry depends on one vendor, that vendor has pricing power, supply leverage, and strategic control over the pace of innovation. If Nvidia stumbles through supply chain disruptions, geopolitical risks, or competitive missteps, the entire AI ecosystem stumbles with them. But here's the twist Nvidia's competitors missed. The lock-in isn't illegal. It's not anti-competitive in the traditional sense. Nvidia didn't force anyone to use CUDA, they just made it so good, so ubiquitous, and so deeply integrated into AI research that choosing anything else became irrational. AMD and Intel are trying to catch up. AMD's MI300 has shown promise in benchmarks. Intel's Gaudi chips have found niche adoption, but they're not fighting for market share. They're fighting for relevance in an ecosystem that has already decided its standard. The question isn't whether AMD or Intel will eventually break Nvidia's dominance. The question is whether it's already too late. Once an entire industry builds its knowledge, tooling, and infrastructure around a single platform, does technical superiority even matter anymore? Nvidia's trap wasn't built with anti-competitive contracts or predatory pricing. It was built with foresight, patience, and a 17-year investment in making their platform indispensable. And now, as the AI industry races toward trillion-dollar valuations and world-changing applications, every single major player is trapped inside a cage they willingly walked into, because when they arrived, it didn't look like a cage at all. It looked like the only door that was open. Asterisk, asterisk 1. Ecosystem beats hardware. Nvidia's dominance isn't about having the fastest chip, it's about owning the software stack that every AI developer already knows, with libraries and tools competitors can't replicate overnight. Asterisk, asterisk 2. Lock-in starts with education. By giving CUDA away for free to universities and researchers, Nvidia ensured an entire generation of engineers would only know how to build on their platform, creating dependency before companies even realized they were trapped. 3. Switching costs are invisible until you try to leave. 3. Moat isn't the chip price, it's the millions in engineering time, lost productivity, and strategic risk required to migrate away from CUDA, making even a superior competitor irrelevant if the pain of switching is too high. If you want more investigations into the hidden infrastructure battles shaping our technological future, subscribe now. Tomorrow, we're exposing the quiet war over AI energy consumption and why data centers might break the power grid before they break even. You won't want to miss it.